have dinner, watch Star Trek, and then I'd get to work designing my own little devices. I just loved everything interesting that modern digital technology could do. And a lot of what was going on inspired me, like the start of arcade games, the digital games based on televisions. I had no money at all, could never afford an output device, and then I realized my television is an output device. Run a wire inside if you know enough about the signals and the electronics and the engineering, you can do it, and started designing little games at night. And then I started designing terminals that could reach the early internet, the ARPANET, when there were only 4 computers you could go to, and 8 computers in the United States when I got into it. 8 computers, 8 different universities was it. And that was so exciting to reach out, like you're getting far away, you know, contacting computers in another part of the world almost. That was just exciting. I had to build my own devices. The only way I could ever enjoy these things was to build my own. That's all I did, just built them, never for a company, never for money. Steve Jobs was a good friend though, and he always wanted to find a way to turn every one of these designs into money, which he did. No, and he did, he had real sales oriented. You'd be surprised, because during that time at HP, of course, I developed, I came up with the model for the personal computer that actually made a useful computer affordable. And I gave it away for free to the people in my computer club, and I said, you know, use this to start your social revolution. Steve Jobs said, hey, let's start a company. You know, the two of us have been selling things for 5 years. Why don't we start a company and just have a company of our own? You know, and the idea was not to have a computer company. It was to have a company that would sell a PC board, a blank PC board with nothing on it. We would sell it to people at the club, and then they could take my design, which I'd given away, and plug their parts in and get a computer built kind of quickly. And it turned into the computer company, which we call Apple Computer now. Very lucky, you know, a lot of things going on, but it was so much fun and excitement as chips, microprocessors, dynamic memories were just coming down enough in cost to make a computer that could really help you and pay for itself valuable. You know, of course, when we started the computer industry, we didn't know what the computers would do that would be valuable. All the big computer companies said, no, it's not going to make it. Well, that inspired us. It gave us even more passion. And they said, no, they aren't going to do the useful jobs. And then all of a sudden came a killer app called the spreadsheet. And these little small computers did more than their big $1 million mainframes. And personal computers were going to be a fact of life forever.
Steve, you've talked a lot in the past about, as technology miniatures, it gives you the ability to do things that you couldn't do before. In fact, you told that story about the first motherboard. I was wondering if you could share that with us, designing and reducing the number of pieces.
Sure. Okay, well, I spent a life really wanting things small, concise. Get rid of the excess, get rid of the junk. Well, theoretically, that's the principle of all engineering. But if you learn the methods in a book, in classes, and you're well taught and trained, you can design a circuit, but it's going to have just as many parts as the book had, just as many parts as everyone else has read, everyone else is doing. When I was young, I discovered computer architectures by accident. Computer manuals describe computers, places they held numbers, methods of ones and zeros were combined to tell the computer what to do. And I sat down on my own with absolutely no class, no books, no training, no way to test myself. Can I figure out how to design computers? Sometimes the best things you do in life are because A, you don't have enough money and you have to find an inexpensive way to do it. Or B, you don't have prior knowledge and you have to find your own way and you have to write a book yourself. And yeah, your first few designs might be very crude and huge numbers of parts and huge costs and not buildable, not reasonable designs. But as you work over and over and over, they say you put a lot of time and a lot of work in, you develop skills. And I started playing a game in high school when we had no computers available in our high school even. I started playing a game. Can I design a computer with fewer parts than I did last month? I would close the door in my bedroom and I'd lock my parents out and I would just sit there on pencil and paper and try to design computers better and better and better with the best parts that were available. And it became a goal of mine to use the fewest parts. to make things simple and direct and understandable. And I used to joke, I came up with designs that were very few parts, sometimes half as many parts as the manufacturers were using. And I used to joke that, oh, it's because I'm lazy. If I ever build one, I don't want to have too many pieces to have to wire together. Yeah.
Steve?
And yeah, so it was always very important to me. Now with the early computer, one of the things that really made things go was I had initially terminals. What you looked at the display of a computer on was attached in a wire. And the computer could send data like letters of the alphabet, text data, A, B, C, D, E, could send letters over to a terminal and would put them on the display. It was all on its own. It had its own language to talk to on the wire that connected it. You know, and the trouble is, that terminal was going to be very expensive. It cost more than a car. Using a television set really saved a lot of money there. But what I did was, in my original designs for Apple, after I wanted the Apple II, I brought the terminal right into the same chips that were used for the computer. And in the Apple I, I started with a terminal design. But it had to count. It had counters that counted horizontal positions and vertical positions. But I was able to reuse those counters. This is how you save parts. You reuse things for a second task. I used those counters to do what's called refreshing dynamic memory. Display addresses so they wouldn't forget what they had, and scan the memory and all that. On the Apple II, I did an even better job. I said, why do I want to have some memory that is what's on the TV display and some memory for the computer? Why don't I make it one set of memory? The computer can get in and talk to the processor, can get in and talk to the memory and change it 1,000,000 times a second. And what's in memory gets displayed on the TV set. So it was really bringing it closer and closer into the one batch, putting the processor next to the input-output that made these products just so beautiful and go so far, and other ideas came in like color.
Steve, you could probably participate with just about any technology company you wanted to these days. What was it that attracted you to Fusion.io, and what was it about our approach at Fusion.io that you found to be a good match?
Yes. Over time, of course, I get asked about 5 times a day to join some company, be an advisor, put in time, and this and that. And, you know, every once in a while I go out to lunch with people that have new startup companies. And I listen to their ideas and I give them my comments. And usually it's a field that's away from my area of expertise. And I don't want to join any companies. When I met the founders of Fusion.io, they described this architecture they had where instead of making a solid-state disk with the NAND flash chips out in a disk drive that you could plug in and be faster, I had those in my life. I loved them. It was sort of pure. It was electronic instead of moving mechanical parts with motors spinning a disk. It was just more pure to an electrical engineer like myself. I asked every question I could, devil's advocate questions, to determine how it did in benchmarks, how much it cost, how fast it was, and how it outperformed disks on RAID arrays. Hugely were the answers. And I understood why, but more than that, they built these chips on a board that plugged right into the server computer, right into the bus of the computer. And I realized that was like what I used to do in the old days. Try to bring everything close to the processor and get rid of all the parts and cables and electronics and decision-making devices in the way, and other processors, which is the normal that you see in a huge data center. You see the server connected over fiber channel cables to disk RAID arrays that split the signal out to several disks to speed things up, and it's still so much slower than the chips in our NAND flash boards. This company, Fusion.io, had chosen to put them on a board that plugs right into the processor. What that tells me is you've got the electrons moving the shortest distance with the least interfering parts making decisions and stalling things. So it's faster, it's cheaper, and it's just better, lower power, everything in every way imaginable. And I came to admire the company quite a bit. Now, it was months later, they actually came back and they asked me if I'd like to join them. By then, I thought tell everybody, this company had the right approach. It was an unusual approach. It wasn't the normal way everyone else was going. These are things I love in my life. I love it when people are doing things a different way. They're not solving the same problem better. They're solving it a totally different approach than everyone else. Of course, all the other makers at the time of solid state are coming our direction. No, it is better technology, and I always favor better technology in the sense that it works better, it costs less to get the same job done, and and it just makes our life wonderful. I mean, we can tell you how many companies, how many things you do on your little smartphones that are fast and quick because they're being served by servers using our cars. So I'm really glad to have joined the company very much. Admire what it's all about, and I'm glad. It's really weird. Sometimes the company says, "Oh, we want to associate ourselves with Steve Wozniak." Nobody gets through the door that way. In this case, I want to be associated with Fusion.io because their products are so great.
Steve, we're at a big show today. Lots of great stuff out on the floor here at IP Expo. I'm sure there were a number of folks who were clamoring last minute to get their demonstrations ready and together and in tip-top shape. You have a story about getting ready for CES at the last minute, putting together a disk drive. Would you share that with us?
Okay, this story is actually very much the reasons that I really fell for Fusion.io and saw that their approach was the way I used to design things. We sat down. First of all, we had a meeting at Apple in our early days. Our Apple II computers stored programs on cassette tape. Cassette tape is slow, it's linear, you have to read from the start of the tape to the end. It takes a while to load in enough kilobytes of program to have it in memory. So what happened was we had a meeting and they were going to allow personal computer companies. That meant Apple, Radio Shack, and Commodore. 3 companies were going to be allowed into the Consumer Electronics Show in Las Vegas, Nevada. Las Vegas, Nevada. We've all heard about it on TV. We've seen pictures of flashing lights. Wow. And this was Las Vegas of an older time, but wow, I would love to go. I've never been to Las Vegas, but Apple was only going to send 3 marketing people. Mike Markla, our marketing guy, Gene Carter, our sales guy, and Steve Jobs. So I was I wouldn't say, well, will you pay to send me to Las Vegas so I can see the lights? But being a tricky engineer, I raised my hand, I said, in the staff meeting, I said, if we have a floppy disk, we show it in Las Vegas. And Mike Markla said, yes. Wait a minute, if I got a floppy disk design in 2 weeks, that I could type run checkbook, run color math, and it would run those programs, I would get to go to Las Vegas. I wasn't being paid a salary to develop a floppy disk drive in 2 weeks. I had a personal goal to see Las Vegas. That's a stronger driver. Now let me point out, I had never before worked with disk drives of any sort. I had never worked with an operating system in my life. I had never studied them. I didn't know a thing about them except that somehow data has to get written magnetically like it does on magnetic tape. And sometimes by not knowing how something's done before, you free yourself up. You say, I am going to come up with the method of doing it. I'm going to write the book on how to develop the smallest, tiniest circuit with the fewest parts, because that was always the way I designed things, that can write data onto this disk. Well, I got a floppy disk. Steve Jobs got a floppy disk from Shugart, and it had a cable that went out to it. And on that cable, it spoke a certain language of ones and zeros. And the ones and zeros told it what to do. I studied their chips on their circuit and figured out what they did. And basically, your computer would have to send a bunch of data out, like text data, and it would get translated into ones and zeros and stored on the disk drive. If you set a command on some of the lines and some data on other lines, it would get written. But you know what? In the end, I figured out, wait a minute, I have a computer I can write software on. And I'm going to send some cables out to that computer telling this disk drive what to do? No. They have one wire that went straight to the head of the computer. Why don't I send the data straight out to the head of the computer, right from my computer to the disk drive? And they had another read head that data came back to your computer. All I need is one wire to, one wire back. And then a few wires to tell it to skip tracks. And I just got around, I said, get rid of all the mess of their chip, their interface, of their changing signals around, and their understanding of a disk language. Get rid of that. Just write some software and send the data straight from my own computer to there. And so I transferred a lot of the tasks was a little hardware I built, and the software that plugs straight into my own computer. And that's what Fusion IO does with their drives, which is one of the reasons I like it very much. Turns out that because of my approach, if I had left a disk drive out there in the open, it had capabilities that were provided by the disk manufacturer. By plugging the card straight into my computer and writing software, I was actually able to, in a later time, add data storage capacity to the disk drive, and I was able to make it faster by making the head track faster than what they were giving us. And this is something that's been true in Fusion IO's case. Our original board that plugs into the server, by changing software, we've been able to improve the speed of that board 4 times. So it's really, when you get close to the processor, there's a lot of amazing things you can do that you didn't even first think of. So yeah, that was a really great experience in my life. My disk drive came out to be 8 chips, and I said, well, how come all of our competitors have 40 chips, and their disk drives have one special chip that's supposed to do the entire job? So I went and studied the competitor's design, and I'm thinking, what did I forget? What did I leave out? What am I missing that you have to have in a disk controller? And after I studied their design, I realized mine did more. So, and it was totally controllable by software, so it could do even more yet. And that's one of the things I like about the Fusion IO approach. We've got a bunch of NAND flash chips on a board. We've got APIs where you can treat them like block NAND flash storage, and you don't even necessarily have to treat them like a disk drive, which opens up a lot of new applications in the future.
You know, listening to that story, Steve, you hear with somebody like your experience that while the technologies change, sometimes the design philosophies remain the same again and again and again. What are some of those philosophies that you've found that have been so successful across your career?
Yeah, you know what? It takes time to do more than just design something. I would generally do a design, look it over, think, is there any way I can shorten it? Use fewer parts, take a piece out. A different approach might save something. Use a chip that was designed for one task to do another task, only because it happens, if you configure it the right way, its inputs and outputs are just right for the secondary task. Always to save parts, which saves money, it simplifies things. It turns out that the reliability of any product is usually proportional to the number of connections you have from different pieces of different of the components. Always try to reduce the complexity that way. That reduces the cost. In the end, reducing the cost is really the big goal. Sure, but I just don't like waste. I don't like, for example, the typical, the SAN disk arrangement, that you might buy coming out of your server computer. You've got, like I said, a fiber optics board that costs about as much as our NAND flash boards cost. On a high-speed cable to a fiber optic receiver at the other end, into a RAID array, and the RAID array spans it off to other disks. And sometimes you have 100 disks with the same data just to try to improve the speed and get the throughput for some of the big social network server farms anyway. They need that. It's just too much in between. Why don't you just have the computer talk directly to the board and supply the data so fast that the computer processor isn't sitting there waiting all the time?
It's no secret that Facebook is a large Fusion IO customer and also has a brand new data center here in Luleå in Sweden. And they talk about just being able to open the windows in order to cool that data center, which is such an important part of data center operations. What do people do elsewhere, and how can they take advantage of new products like those from Fusion IO to help save energy?
Well, yeah, we've got an amazing number of white papers that are on our website that describe people that have actually installed Fusion IO boards into servers, found out that the servers became so much more efficient, they reduced their number of servers down 1/5 or 1/10 as many servers to do the same job just as fast. They sometimes save a lot of money on per core license fees from companies like Oracle. And in the end, when you cut your number of servers down so hugely in quantity, you're cutting down the total power usage. You're cutting down the total square feet you're using in the data center. Every one of these things is along the lines I like to do, which is reduce size, reduce complexity, reduce amounts of components. And now the servers are more efficient. They're using less power. You save that on your air conditioning bills if you don't have an ability to open windows. And it's just a story that we're hearing over and over and over. Countless.
Your perspective on some of the big trends today, cloud computing, and particularly I'm curious to get your opinion on sort of the connection between the devices we use on a daily basis and the data centers that are on the other end of that connection.
Yeah, a lot of people think, wow, we've got these powerful computers in our pocket now, our mobile devices, and they truly are the most incredible computers of all time in a small package. But really, most of what you're doing that relies, getting answers to questions, getting directions, contacting other people, being in communication, it's all going through data centers. And the servers in the data center are doing the massive parts of the actual calculation. They also are in tune with the massive amounts of information. You might ask questions, maybe it's a Wikipedia type question, maybe it's asking just data about distances between cities, but it's really the data and the calculation is being done out there more in the cloud and the data centers. You don't see that. What you see is how fast a response do I get and how accurate is information and how much data does it tap into. So really the whole move to the cloud has pretty much been made. It's not like a move that we're in the middle of right now. Big data is coming. We've got a lot of voice content. We especially, whether it's music coming your direction or your voice going out to the data center to interpret what your words were and what they mean. Huge amounts of data that way. You know what? We're moving towards a visual arrangement where we're going to actually communicate a lot visually over the internet to determine what am I looking at. Google Glass is a step in this direction. So we're going to have more and more data and computation in the data centers, and I think that portends a great future for Fusion IO because we're the leader right now in making it efficient.
Changing tacks for a little bit, going back to some of your entrepreneurial activities, I'm sure there are a number of folks here who are working on their own projects. What are some of the general advice you have for folks who are trying to develop new technologies, but also not just the technology side, but developing new businesses? What are some of the lessons that you learned over your career?
Yeah, well, if there was a formula that you could write down, here's how you develop a business and have a success, well, everyone, every analyst smarter than me in these ways would be able to go out and start these successful companies. They're still kind of rare. The ones you hear about, the ones that become, so huge, Apple and Google, Spotify, that's still too rare to really give one formula. When you meet young people, I like to tell them, you know what, you're going to have a few little small products that aren't worth a lot of money. And eventually, if you keep developing products, you're likely to hit a home run that puts you in the big time. Also, you need to have confidence that you can actually make it. And try to develop as much as you can before you seek outside money. Everybody says, oh, I'm trained in business school. I'll have an idea, I'll write it down on paper, I'll type up a business plan, and then once I get it funded, I'll go hire some engineers. I always say, make sure you've got engineers involved in creating the definition of the product you're going to build. Better yet, have a working model or at least a virtual demonstration on a screen of your model functioning before you go out and seek money, because then you'll have a much better story to tell and you'll own more of it.
Steve, it's no secret that you love music. Going back to the US Festival as an example, maybe we can ask you a story about that later. We recently talked about Spotify being a Fusion IO customer. Do you use Spotify?
You know what? I have very few music programs on my iPhones and all that, but I do carry Spotify on it. I'm afraid to try Spotify so far because a long time ago I tried Pandora, and it sort of understood me, and it just ruined my life because I couldn't get to sleep every night. The songs that it would bring up. I don't really use the Spotify yet, but I sure am after this trip going to be using it. I iTunes, and I've got such a huge collection of my own music. Very much into music. Go to about 50 concerts a year, and as much as I have time for it.
And I have to ask, are you an ABBA fan?
Well, you know what? I did take disco lessons back in the 70s, and actually danced a little bit. I wouldn't say it's the heart of my current music.
Staying on the music theme, tell us a little bit about the US Festival, a story or two.
Oh my gosh, the US Festival. Well, my life had always been one actually Steve Jobs and I spent a long time talking about our common music interests, and we were looking for guiding philosophies of life in key songs, that some of these brilliant intellectuals that were creating music and songs, that they were able to see life in ways that helped inspire young people like ourselves. And it was a big part of our life. Well, and there came a point in time when, oh my gosh, Apple was so successful, and I'm the only one who just wanted to create computers. I didn't want to have any big wealth. I didn't want to run companies, and I had all this wealth. And I thought, my gosh, why not have a big music festival that brings people together to hear and be inspired by new ideas, you know, sort of direct us in life. I get a lot of emails almost every day to this day, people that were very affected by my huge music festivals. But one of the things was technology. Personal computers were new. They weren't that well known. Not everyone had a computer yet. So we had a huge set of tents showing off personal computers and the various accessories that were being developed in those days, including music production services, all in tents of music. So it was a combination technology fair and music on a stage. And that was the big part of my festival. It was very different and very notable.
Getting back to the mobile world and all the applications, what are some of the favorite applications? You're a big mobile phone user and iPhone user. What are some of your favorites?
You know, I look at the end of the day, sometimes I look and, oh my gosh, I used 30 apps today. And every one of those apps was very important when I used it, except the overall operating system of the device. And I have multiple devices, multiple platforms that I use a lot. And Siri, I like to speak to all my devices. I like to ask questions, I like to give it direction, I like to send emails and notes that way. So I'm going to say Siri is probably number one for me.
It's also, you travel with quite a lot of gadgets, a big heavy backpack. Tell us a little bit about your gear there.
Yeah, I am a gadget guy. All my life I've like hooking things together, finding them. It's sort of like the modern toy is in your gadgets. All the apps that you get on your phone are toys to us adults. I mean, I would take my young child to the carnival and I'd pay $80 to throw darts at balloons so he could get a bigger stuffed animal. And and we get all our apps for free, for $1, for free, for $2, and these are just the fun part of life. So I forget what the question was. Something in there.
Tell us a little bit, we have a lot of folks here, obviously in the technology industry, and all trying to develop new things. What are some of the words about what you see, given your view, some of the things in the next few years, technology-wise, that we should all be aware of?
Yeah, I'm pretty much aware partly of technologies that we read about a lot. For example, foldable displays, and they're going to pop up in televisions and all that. But I go beyond that. I think, what if you had a globe that glowed, Google Earth? You could somehow tap and zoom in on areas of it, but it was really in the shape of a round globe. Or what if you had little plastic panels that, cellophane panels that was attached to your car doors, and you could press a button and change your car from blue to red, or make it look like a cop car. And so I think those technologies, I think voice is going to become more and more prominent. I actually find that when I use my voice, I don't have to think of a procedure. And a long time ago, I really got tired of thinking out all the procedures that you tap, 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 tap. You look like a super expert, because I'm never going to be as fast as the young kids at doing that sort of thing. But if I could just speak my voice and it happens, and I might not say it the same way every time, but a human being would understand me. Human beings are very robust. Lots of different input has the same output. It's robust. And so I think voice is going to become more and more prominent feature of the devices that we have in use. I can be in a noisy environment and still almost whisper to my iPhone and it still be understood. So that doesn't mean that just because other people are around, you can't speak what you want to. Ease of computing, to me, means when you feel that your mind is doing less work and less thinking about the methodologies and the procedures. For example, when I worked at Hewlett-Packard, our calculators used a system called reverse Polish notation. Reverse Polish notation is part of computer science, and you as the human had to think out the order to type things in to get your equations solved. Then our competitors came out with calculators that used arithmetic expressions, parentheses, told it what order to use. And we laughed because young children are taught about enough. The first time we had one of those calculators in our lab at Hewlett-Packard, we had a huge statistics equation, very long and complicated, hard to get the right answer. And I thought I was the smartest one, so I said, I'll try it on this Texas Instruments calculator with parentheses. And I looked at the equation and I said, okay, here's the part that's going to get executed first. So I'll have to work myself in and out. I'll put in about 5 parentheses, maybe 6, maybe 7. And then I realized a human being is never going to remember what parentheses level they're at as they work themselves out of a complicated enough equation. Wipe my head clean, like Socrates says. Wipe my head clean. I said, this calculator can do the job. I have to come up with a method to do it. And you know what I got? I said, just type it in from left to right. I typed in everything on that equation from left to right, making a couple little guesses as to whether the square root was first or second. And as fast as I could type, and I got the right answer the first time. I showed it to the other HP engineers. They couldn't believe it. And I told each of them, type it from left to right. And this was where we got into a real problem. Not one of them could do it. They didn't understand me. They thought you had to use your mind to think out the method to solve the problem, to think out the ordering of things. They had learned a skill, and they didn't want to give their skill up for something easier that came along. So very often when you develop an easier to use technology, it doesn't get recognized. Now, as far as what I want to see in the future, a lot of it comes from the very first day I got the first PDA in the world, the Newton message pad from Apple Computer, long time ago, back in the 90s. And I was in an airport, I got a phone call, and I wrote a little note to myself with my own hand muscles. You can handwrite. And I hand wrote a note about my daughter, Sarah, dentist, Tuesday, 2 p.m. That's all. And then there was a button called assist, and I didn't know what it did, and I clicked assist. It opened up my calendar, Tuesday at 2 p.m., it put down dentist, and it grabbed Sarah out of my contact list. I said, oh my gosh, I wrote a note for a human being, and the machine understood me. This is what I want all machines to do eventually. And so I'm still on that track, and voice gets us very close, because once you understand voice, you are doing what's in human terms.
Great, well I think we'll wrap it up there. Woz, thank you so much for joining us, and we'd like to give you a big round of applause. And for those of you who would like to take a photo, you're more than welcome to. We'll have the photos posted later on at facebook.com/fusion.io. Again, I want to thank everybody for coming, and I hope you have a great IP Expo.